Now, whenever we're dealing with logarithmic functions, we have to be concerned with the domain. It's just like when we're dealing with even index radical functions, like the square root of x. We have to be mindful that the domain is x is greater than or equal to 0. Or when we're dealing with a rational function where we have an independent variable in the denominator, we have to be concerned, for example, 1 over x, we have to be mindful that x can never be 0. So with logs, we have a similar situation. Remember, what I've done here is I've just graphed the natural log of x as an example. Notice that it's asymptotic to the y-axis. In other words, the domain for the log normally goes from 0 to infinity, not including 0. So it's parentheses, 0 comma infinity. But let's suppose that we have something in here, in the radical, like x minus some number. Well, let's see what happens. Normally the asymptote is the y-axis, x equals 0, but let's see what happens. What if a is 1? Notice that now the domain is not 0 to infinity, it's 1 to infinity, right? See? You see the asymptote here? So the graph has been shifted over. Or if we make it 2, you can see how the graph is shifted over, so the domain changes. So if a is 4, the domain is 4 to infinity. Now we could go the other way. We could come back over here and say, well, what if a is negative 1? That would be x plus 1. Well, now in here, so now we say, okay, the domain would be negative 1 to infinity. And you could see how this works. See? As we change a, the domain changes. In other words, the domain is dependent upon what's inside this log. So here's the thing. With logarithms, you can never take the log of 0 or a negative number. So our concern when we have a logarithm like this one is that we never try to plug in anything that's going to result in us trying to take the log of 0 or the log of a negative number. So we have to do some investigation. So we take this 2x plus 3, set it greater than 0, and solve it. And we find this, that 2x plus 3 is going to be greater than 0 as long as x is greater than negative 3 halves. Or another way to write it in interval notation is this, negative 3 halves to infinity. Not including negative 3 halves, because that would be where the log, that would be where 2x plus 3 is 0. Okay, and here's what the graph looks like. Notice, here is the vertical asymptote, x equals negative 3 halves, and our function goes to the right of that. If we plug in any value for x over here, we're going to get 2x plus 3 to be positive. And that's what we want. If we go to the left of that asymptote, that won't work, because then we'll be trying to take the log of a negative number. Now, let's look at another one. G of x equals log base 3 of x squared minus 16. Once again, we're concerned, where does x squared minus 16, where is it greater than 0? Well, one of the ways that we might proceed with solving this one is just to consider, well, where are the transition points? Where does it go from being less than 0 to greater than 0, or greater than 0 to less than 0? Well, those happen here at the boundary. In other words, those happen wherever x squared minus 16 is equal to 0. So let me solve this, and then I'll use that to divide up the number line. But here's what we do. Let's just solve this one. I factor it, and I find that x equals plus or minus 4. Okay, so I just solved this simple quadratic equation. Now I use those boundary points to divide up the number line. Everything less than negative 4, everything greater than 4, and everything between negative 4 and 4. Those are the divisions here. So I pick representative numbers from each region. Negative 5 for everything less than negative 4, 0 for the region between, the interval between, and 5 for the interval, that region, the x values above 4. Okay? Then I test those. I plug in a negative 5. Dig what I have here now. I have negative 5 minus 4. That's negative. Negative 5 plus 4. That's negative. Negative times a negative is a positive. Jackpot. That's greater than 0. That's part of my region. That's part of my domain. This thing over here, this region right here is part of my domain. Now let's plug in the 0. When I put in a 0, I get a negative 4 times 4. That's negative. So that's not greater than 0. So we don't include that one. Let's try 5. Well, 5 minus 4 times 5 plus 4. Positive times a positive. That will work. So we get our domain. Negative infinity to negative 4. All of this region over here. Union with 4 to infinity. All of this over here. And here's what it looks like. We see our vertical asymptotes here. And the function goes off this way and this way.